All right, so here we're going to take a look at two-step energy problems. So previously we've only been dealing with one type of energy being changed at one time, so either a heating or cooling problem only, or a phase change problem only. So here we're going to take a look at what happens when we have both. So how much energy must be absorbed by, this was supposed to be 200 gram sample of ice at 0 degrees Celsius that melts and then warms to 30 degrees. So I want to figure out how much energy is used up this entire event. First thing I want to do is go ahead and decide if this is a heating or cooling event. So because this thing is warming up overall, this is a heating event, so I'm going to go ahead and draw myself a heating curve. Now, I want to figure out what regions does this occur on. Well, it's at ice at 0 degrees Celsius, so I'm going to start at 0 degrees Celsius, and it melts and warms to 30 degrees. So 30 is probably somewhere around here. So that means that this event is happening over these two regions. This first region here, and then this second region. So on the first region, I have a solid to a liquid phase change. It's going from ice to water. On the second region here, I have a heating event. So I need to figure out how much energy occurs over both these events so I can figure out how much energy is absorbed. So in the first event, it is a phase change and it's solid to liquid, so I'm going to use my heat of fusion. Heat of fusion is used for melting or freezing. So Q is the energy absorbed, M is the total mass that is melted. In this case, that is 200 grams. And heat of fusion, I look at my energy constants, and my heat of fusion is 334. So that tells me that I get 66,800 joules of energy. We can't forget our unit. So this here is the energy absorbed to melt the ice. Now, we have kind of this second stage. So we have heating. So it's continuing to absorb energy and it's going to heat to 30 degrees Celsius. So heating, I know I use specific heat. So M is the mass that's being heated, and the total mass that's heated is 200 grams. Specific heat of water is 4.18, and change in temperature. So this thing starts at 0 degrees. So remember that delta T is always final minus initial. And it ends up at 30 degrees. So here, we get a little over 25,000 joules. This is the energy to heat the water. So because I'm having an event occur on two regions, I need to use two equations. This first equation here tells me how much energy did it take to melt the ice. This equation here told me how much energy did it take to heat it over this interval. So it was asking for how much energy must be absorbed. So that means that the total energy that's absorbed is the energy absorbed to melt the ice plus the energy then absorbed to heat it once it was a water. or 91,880 joules. So that's one example of a two-step heating problem or cooling problem, where you have to figure out how much energy is absorbed over the two events. Now, this one's a little easier. The one that's harder is where you are given the amount of energy, and then you have to figure out what is the final result. So let's say you're making pasta and you forget about it. The stovetop transfers 330,000, I just want that to be joules of energy, to 350 grams of liquid at 20 degrees Celsius. What mass of the water will be boiled away? So let's go ahead and draw a heating or cooling chart. We have 0 and we have 100. Now, obviously this thing is being brought to a boil, so that's gonna be heating. So I'm gonna go ahead and draw a heating curve. Now, I need to figure out where it starts. Well, it starts out as liquid water at 20 degrees Celsius. So 20 degrees Celsius is gonna be somewhere over here. And it goes and it's boiled. So boiled is going to be a liquid to a gas phase change. So I need to figure out where on this graph would a liquid to gas phase change occur. Well, we remember that the two flat lines are where phase changes occur. This one down here would represent a solid to a liquid, and this one would be liquid to a gas. So that means that my final point is going to be somewhere along this region. So that means that my event is taking place over these two regions here. And I started with 330 joules of energy. So this is kind of like my budget. I have this much energy to spend, and with this much energy to spend, I'll need to figure out how much I can boil it away. Well, to do that, I first need to figure out how much energy is required to heat it. So I kind of have 1 and then 2 on this side. So 1, how much energy is required, or how much of my budget do I have to use just to heat it? Well, for heating it, I know I'm using this equation here. So the mass of the water that's being heated is 350. Specific heat of water is 4.18. And the change in temperature, well, it's starting at 20 degrees. So my start is 20. And the final is the maximum I can heat it when it becomes boiling. So boiling occurs at 100 degrees. So its final temperature, 100. So that tells me just to heat it, I had to use, so I used this much energy just to heat the water. So my original budget was 330,000. I used 117,000 of it, so now what I have left over is 330,000 minus the energy I spent to heat it. Which is this here. So I have this much energy left over. Now, with this amount of energy left over, I want to figure out how much I can boil away. So if I'm talking about boiling, that is in stage 2, that is heat of vaporization, a liquid to gas phase change. So I started with 330,000. I used up 117,000 to bring it to a boil. Now that means I have 152,000 left over to start to evaporate it. And I want to figure out M, the mass of the water that would be boiled away. So here, I'm going to use the heat of vaporization, which is 2,260. So M is equal to 152,960 over 2260. And since it's a mass here, I'm going to want to make sure I have the appropriate units, which is grams, or 67.68 grams have been boiled away. So these are the two styles of two-step we could see. We can see either one where we have to figure out how much energy was absorbed or transferred out of the system by figuring out how much energy was used in this first process, how much energy was used in the second process, and then adding them together. The other is where they give us kind of this energy budget. They say, if you have this much energy, how much could you either raise the temperature or boil it away? So here I figured out, well, out of this budget, I used this much to go from here to here. And then I had this much left over, and where that took me over the